Right, guys, this is the second question from 3-4, and this is one where you have to graph your linear inequalities and then identify your vertices and then test those. All right, so looking at number 6. So you have x plus y is less than or equal to 8. So let me go ahead and jot that down. So x plus y less than or equal to 8. In order to graph it, we have to solve for y. So we're going to subtract x from both sides. And you have y is less than or equal to negative x plus 8. So your y-intercept is 8, and your slope is negative 1. So you're going to go down 1 to the right 1, down 1 to the right 1, and just keep on going. Draw your line. Oh, let me undo that one. Whoops, not what I wanted to do. Let's see. All right, here we go. Let's try that again. I don't know if it's going to be any better this time or not. All right, and then it says y is less than or equal to, so you're shading below this line. All right, the second inequality we have is 2x plus y less than or equal to 10. So you want to solve it for y again. This time we subtract 2x from both sides, and you end up with y less than or equal to negative 2x plus 10. Right, so we're going to go to 10 on the y-axis, and then your slope is negative 2, so you go down 2 to the right 1, down 2 to the right 1. Hey, that's where they're intersecting. Down 2 to the right 1, down 2 to the right 1, and there we go. Right, so now we're going to draw that line, okay? And it says y is less than, so again we're shading, and we're shading in this region. All right, going back up, x is greater than or equal to 0, so that one goes through the x-axis and also happens to be the y-axis. Greater than means you're shading this way. And then y is greater than or equal to 0. It happens to be your x-axis, and you're shading above. So your solution region, feasible region, is right here, leaving us with points 0, 0, 0, 8. This point is at 2, 1, 2, 3, 4, 5, 6. And then this point down here, which is 1, 2, 3, 4, 5, 0. Okay, so those are the 4 possible solutions because those are the vertices. So you're going to write those down. 0, 0, 0, 8, 5, 0, and 2, 6. Now the equation that maximizes that, the objective function is 100x plus 40, and we're looking for the maximum. So 100x plus 40y. So that's going to give you 100 times 0 plus 40 times 0. This is 100 times 8 plus, 100 times 0 plus 40 times 8. This one is 100 times 5 plus 40 times 0. And this one is 100 times 2 plus 40 times 6. 100 times 0 is 0. 10 times 0 is 0. 100 times 0 is 0. 40 times 8 is 320. 100 times 5 is 500. 40 times 0 is 0, so this is 500. 100 times 2 is 200, plus 40 times 6, which is 240. So 200 plus 240 is 440. And again, we were looking for the maximum for that function, and so 500 is the largest value, so that means the maximum occurs at 5, 0 with a value of 500. Okay. All right.